So welcome. Let's start with the session two. In last session we understood about the resistor, about the LED, what is resistor, what is LED that we have discussed, and we also made this circuit on our Tinkercad software. So in that we use the LED, resistor, and battery, and we try to make the circuit with the help of that to make the LED on off with the help of battery. We understood the importance of resistor and LED, resistor and everything in that. Correct. So right now what we are doing is we want to discuss more in depth about the LED. So we are discussing more on LED, like what is LED again we are discussing. So LED is a light emitting diode that you know. Now this is the symbol of LED that we have not discussed. This is the symbol of LED. So now what is diode here? Light emitting diode. So what is diode? So now we will discuss in depth. A diode is a semiconductor device with a terminal typically allowing the flow of current in one direction only. So a diode and light emitting diode. So light emitting diode is also one type of diode. So this is also having the same feature which diode is having, but the both separately also are available. So LED is all can be used, and diode also a electronic component that is also used in the electronic circuits. So diode is a two terminal component which allow the current in one direction only. What is the meaning of that? So if you connect the battery positive to the anode, so this terminal is called anode, the one terminal is called anode, the second terminal is called cathode. So this is positive, this is negative. So I have to identify that also. We discussed yesterday and that Tinkercad software, and that LED we discussed that the LED which is very straight, that is cathode, and which is having some angle, that is a anode. So anode is act as a positive, cathode is act as a negative. So when you connect battery positive with this anode and battery negative with cathode, this diode will work. So current will flow and electron will flow. Now diode is not light emitting diode, so it will not emit any light, but the current will flow through it. But same way, if you connect the LED in the same manner, like positive with anode and battery negative with cathode, then it will glow the LED, means it will emit the light, right? So if you do the connection in reverse, so like positive with cathode, battery positive is with cathode and negative with anode, then current will not flow. So diode will not allow to flow the current through it. So the circuit will not complete, and there will not be any current flow in that. So it's like a switch on, the circuit is breaked, so there is no connection in the circuit. So when the you connect the reverse, the current will not flow through it, and so the it's like a obstacle in between it. Okay, so how it works, let's discuss again more. So current will flow if you connect positive with the anode and negative through resistor cathode. The current will flow like this, and LED will emit the light. That is correct. Now if you connect in a reverse manner, so here if you see, positive is connected to cathode and negative is connected to anode. So if you connect this manner, the current will try to flow, but here it will get stuck. So it will not allow to flow the current, and that is the reason the LED will not get on if you do the reverse connection. So if you do the reverse connection, LED is not getting on. It doesn't mean that LED is not working. The meaning of it is that you have connected in a reverse direction. So you have to connect in a proper direction, the correct direction, that is anode should be the positive and the cathode should be negative. So this discussion is important. So I have discussed this again so that you understand in a better way. So hope it is clear. Still, if it was not clear, please note it down and please discuss with me in the Skype session. So current will not flow allow. It will not allow. Now let's discuss about the battery. So what is battery? Battery is a cell in which chemical energy is converted into electrical energy. So in the battery, the chemicals are there, and that chemicals, due to the chemical reactions, electricity is generated, and that electricity we are using as a electrical energy. So what is happening in the battery? chemical energy is converted into electrical energy. A very basic definition. So what is battery? A battery is a cell in which chemical energy is converted into electrical energy. So this is the symbol of battery. So if you see the any circuit of the electrical circuit, you will find this type of symbol. And if you want to draw the circuits, you have to draw this type of symbol to make the circuit. And this is the luminous battery. So this is the luminous battery life, that is the battery, big battery which is used. So let's go further. So you discussed the definition. Now how battery works basically means how chemical energy is converted into the electrical energy and how we are using it. So let's discuss that with the help of this video. So this is the video. So can you imagine, I'm reducing the voice volume here so that you can discuss everything. So I have reduced the volume of the music so that we can discuss. So I am again restarting this. So can you imagine a world where all electrical appliances to be plugged in? So if battery, if not there, if it is not invented, then there will be a great problem. So you will not be able to play with the toys because battery is not there. So battery provides portable convenient source of energy for powering devices without wires and cables. So it is a dry cell. It's a common type of battery today. It's basically convert chemical energy into electrical energy. So in the most basic term, battery cell is made up of three components: anode, cathode, electrolyte. So anode is made up of zinc, cathode is made up of graphite, and this is made up of ammonium chloride. So these are the chemicals which is used in the battery. So due to the chemical reaction between the anode and electrolyte, the chemical electrons are generated. This excess of electron tries to move from anode to cathode to balance, but they are not able to move due to this electrolyte. So electrolyte not allowed, does not allow to move from anode to cathode. So when you connect some wire through bulb or remote, the electron get the path to move from anode to cathode to balance the electron. So the main motive of electron is not to glow this bulb. The main motive of electron is to move from anode to cathode to balance the electrons. Okay, so in this way they tries to balance the electron from anode to cathode, and when there is no electrons available, so we say it as a battery dies. So battery is over, we need to replace the battery in the remote. Whenever we say that, its meaning is no electrons available in anode. So that way battery provides us a mobile source of power by which we can use our toys and everything. So in this way this battery is working basically. So hope you have understood this. So again I will go there. So it's over now. So now application. So you hope you have understood this battery working. If you are not clear, please write it down. We'll discuss it again. We'll see the video. You can see the video again and again as the video is available with you. So you can see the video again and again, and you can identify your doubts and write it down, and then you can discuss with me on this Skype call. Now application, where the battery is used at home. So remote control, we use the battery. Toys, bike and car. In bike and car, where battery is used basically, it is not used in the tires, okay, because the tires are rotating with the help of engine, with the help of petrol. It is not working with the battery. So battery basically used in car and bike is for headlight, for to run the that music system or AC. Okay, to start the bike we require the battery, to start the car we require the battery, but to run we require a petrol. Okay, so the battery is used for bike and car. Then inverter is the emergency light which is required, which we use generally at our home. If you have inverter in your home or in other wherever you have seen, so the application is like when the light is there, the battery available inside that inverter get charged, and when there is no light, the inverter convert that battery energy to the electricity, and that electricity we use at our home. Then mobile watch and laptop, in that battery is used. So you are clear with the battery concept. If you are not clear, please write it down, the concerned doubts, and we can discuss. Now we'll discuss about the switch. So what is switch? A switch is an electronic device which can break or make the electrical circuit. So it is an electronic device which can break the electrical circuit. So you can see in the circuit diagram, the simple, if you see, this is the simple diagram in which the switch, battery and bulb is shown, and this is the circuit diagram of it. So it's a symbol of switch, this is a symbol of bulb, and this symbol of battery. So battery symbol is not shown proper, so that is okay. So when the switch is on means this is closed, so the power is going to the bulb, and so bulb is glowing like this. So practically you can see here, theoretically in a circuit manner you can see here. So this is the pictorial circuit diagram, we can say, which is having the pictures. This is the circuit diagram which is having the symbols. So in this way, switch is basically what it is doing. It is making and breaking the circuit of the bulb. Very simple. So like this is the another example at home. Generally, if you have seen the circuit, like at home, we have the two switches to control the single light or fan. Okay, so one switch is are near the bed, and the second switch is available at the door. So when you make the switch on with the help of switch near your bed, the fan, and when you are leaving the room, you can switch off that fan from the other switch also. This example is shown here, the same example which I have discussed right now. So this switch is suppose near the bed, this switch is near the gate. So when you switch on this, then also it will work. When you switch on this, then also it will work. So that way we can make an on and off this circuit with the help of these switches. So there are different types of switches actually, according to the application. So here you can see the switch is of different type, and here you can see this is a different type. So how much types of switches actually are there? So there are four types of switches available in the market. So that is the SPST. First type is SPST, that is called single pole single throw. Second is SPDT, that is called single pole double throw. And third is the DPST, that is called double pole single throw. And the fourth one is DPDT, that is double pole double throw. In this way we have the four types of switches. Now we will discuss each and every switch in more depth. So let's discuss it all these switches in more depth. So let's do it again. So what is SPST first? SPST is a single pole single throw. So single pole single throw, what is the meaning of it? That we'll discuss. So it is the simplest switch. It connect and disconnect the one terminal either or another. So it basically used to make and break the circuit. So what is single pole and single throw? Single pole means the moving part, it is called pole, and throw means where it is throwing. So single pole single throw. So pole is one and can throw at one direction only. That is why we say it as a single pole single throw. Then single pole double throw. One pole is there and it can throw at a two direction, this one and two. So single pole, the moving part is one only and it can throw at two direction. So the example you can see we have discussed previously. So this is the example of SPDT. So this switch can throw at two direction, here also and here also. So the same example at home we generally use this type of SPDT. Then single pole double throw, then double pole single throw. Two poles are there but they can throw in one direction only. It means that they both are connected mechanically. So this two poles are connected mechanically. This dotted line indicates that they are connected mechanically. So it means that this if you press this switch, the both the switches will move simultaneously when connected to this terminal, and when you release it, both will disconnect. Okay, so that is called DPST, two pole single throw. Then double pole double throw, two poles are there and they can throw in a two directions, so both are mechanically connected, still they can throw here also and here also. So at one direction, at when you press this switch, it will throw here. If you press in a reverse direction, it will throw here. So that way it can throw in a two direction. So that is with two pole and two throw. So that is why double pole double throw. So in this way, the four types of switches are available which are used as per their application. So generally at home, all the switches are SPST or SPDT. So SPDT is the example of the double side switches, and all other switches are SPST switches. So the light and fan are of SPST, doorbell are of SPST. So now you can discuss with your parents also that which type of switches we are using. So we are using SPST switch at our home. Okay, so now let's make the circuits in the Tinkercad software. Further, we'll do the practicals now. Last we did the practical of battery and single LED. Now we'll again proceed further with the switches, how to connect the switch in the circuit and how to make the circuit with the help of switches, that we'll discuss now. So let's go to the Tinkercad software and then we'll start the circuit. So let's go to the Tinkercad software. So we have reached to the Tinkercad software and we are going to create a new circuit. So let's create a new circuit. So I have created a new circuit. I am renaming it. So you have to rename every time whenever you are creating a new circuit. So session 2, robotronics part 1. Okay, so you can rename it like this: 1, session 2, robotronics part 1. So now let's have, now we'll make the circuit first, a basic circuit, like we'll have the battery, we'll have LED, we'll have resistor. Why we have to use resistor now it is clear. So let's make this some basic circuit like we have done in the that first session. So the positive, now negative is connected to black one and the positive is connected to resistor. Now if you simulate it, it will get on. So it's on. Okay. So very easy, practical for the connections. So now this should be very clear how we are doing the connection. So this is anode, so positive and negative. So positive we are connecting to the resistor. So the positive battery to resistor to it is going to the LED, and negative is here. So now we do the simulation. So LED is on. So this is very clear. Now we are adding the switch in between. So we can add the slide switch also, we can add the push button also. So let's go with the slide switch first. So I'm connecting a slide switch in between. So slide switch have the three terminals, as you can see, one terminal 1 common and terminal 2. So terminal 2, as you switch on and off, it will get connected, means common will connect it to terminal 2 basically. So you have to use that only, like I will show you how you can use it. So you can do the connection like positive you can connect here, positive you can connect here, and negative, this negative is going to common. So I am giving the direction to the wire so that you can understand in better way. So this, and this terminal is goes to negative. So how the circuit is flowing, from here the current will flow to the LED, to the switch, and to the negative. Now right now switch is off, so I am zooming it, you will understand. So this position is showing that this both terminals are on and this is off. So when I am starting simulation, so when I switching this, it is on, now it is off, on, off, on, off, on off. Basically what, this both this both terminals get connected, means this both are on, this both are off now. So you can see the LED is on now, LED is off, LED is on, LED is off, LED is on, LED is off. So this way you can do the connection of the battery with the LED and switch. A very simple circuit that you can try. And now what you can do is you can try the other battery also if you want. Like you want to try 1.5 cell or that cell, this 1.5 is 5 cell battery, you can change like 1 2 battery, 3 battery. Okay, so that way the voltage will increase, the power will increase as you increase this battery level. Okay, so I am using right now one battery, so you will see that with the one battery the LED will not glow, because with the one battery its power is very less. So let's see. So as you start, very dim LED is getting on. So this is off and this is on, off, on, off, but very dim. Okay, you're not able to see how much it is glowing basically, right? So let's increase the power. Two battery, three battery, two battery. Let's do the two batteries. You will see what is the change. So now it's glowing better than before. So let's increase now 2 to 3 battery. Now you will see that the glow is increasing. So you can keep it on and you can change the battery. You will see the how much it is glowing. So 1 very dim, 2 slightly more, 3 or more, 4 more and more. So this way you can see how the battery, how the battery level is increasing, how intensity of the LED is changing with respect to power. Okay, that you can do the simulation, that you can try with this type of circuit. Okay, so this way you can try with the sliding switch. Now you can use the push button instead of sliding switch. So okay, so what I am doing is I am deleting this and I am using the 9 volt because the basic requirement is, or you can use the coin cell also. This is also fixed 3 volt you can use here. So the one terminal is connected, this is negative, it is written, so positive is connected here and negative is connected here. So if you see the simulation started, the switch is on, so it's on and off and on, so on, LED is on because it's a 3 volt power. So if 3 volt, if the voltage is above 3 volt, the LED will show you the on. If the power is less, then the LED will not show you on, it will it will be very dim. So if you use 9 volt, so if you can see 9 volt, I am connecting here positive and then negative terminal directly to here, and if you see the simulation and on, it's glowing more brighter. Okay, so it depends on the power also, it depends on the resistor also. So here we have used 1 kilo ohm, so instead of 1 kilo ohm we will use it blast actually, so we have to use 100. So 100 is also having more current, 100 ohm, because of the 9 volt battery, and it is having a 65 milliampere, which is very high because it recommended is 20 milliampere, so it works on 20 milliampere only. So we have to increase the resistance to 200, it will not work, 300, it will not work, 500, it's okay. So at 500 we are not getting any message, so 500 ohm resistance is okay with it. So by this trial and error you can identify the resistance value. Okay, which resistance value will work for which circuit. Okay, so like here 500 is working for 9 volt and LED, so that's correct. So how to identify the value of resistance, that you understood now. So this way you can identify the resistance value. Now I am stopping the simulation and I am doing the circuit 1, session 1, circuit 1 I will give, because yeah, circuit 1. Okay, so that the rename, I did this rename of session 2 circuit 1. So I am now going with a new circuit where I will use the push button. So let's go for the push button, new circuit, and we are going to have the push button now in our circuit. So battery 9 volt, LED will use the resistor, will use the push button, Okay, so the connection will be like positive. So we want to go with this. So positive will go to resistor, negative will go to resistor to negative. Now positive we can give to the push button, and the push button is going like this. So we have connected. Now push button connection, you need to understand. So there is four terminals in this push button. So this 1A and 2A, 1 and 2, this indicates that this is a 1 SPST switch. So when you press this, this 1A will get connected to 2A, and 1B will get connected to 2B. So let's see how. So I have started the simulation. When I will press here, the LED will on. When I will leave, LED will off. On, off, on, off, on, off, on, off, on, off. Okay, so this means that when you press this switch, SPST switch get closed, and due to which this 1A and 2A get closed, and that is the reason LED is on. When you leave, it breaks the circuit, and so the LED is not glowing, so electron is not flowing now. So with the help of this switch you can control the two LEDs. So let's have two LEDs now. So with the two resistors, so the positive, now negative I am giving to this resistor, and same with this here, positive here, and the where it will go, negative, positive. Okay, so this may confuse you, but if you are clear with the circuit, it will not confuse you. Okay, if you are not clear with the circuit, then it may confuse you. Okay, so now if you simulate, so I have started the simulation. When I will press, both the LED will on. When I will release, both is off, on, off, on, off, on, off. Okay, so in this way we can do the connection. We can control the two LEDs with this push button. In this slider we have not discussed for the two LEDs. That is also we will discuss now. So this is very clear now. I am giving this name as uh, session 2, circuit 2, robotronics part 1. Okay, so I'm giving the name now. This is very clear, I think. Circuit, the push button, the circuit should be very clear. So push button, this is a 2 SPST, combination of 2 SPST. So 1A is connected to, when we press the switch, 1A will connect to 2A, and 1B will connect to 2B, and that is the reason the one LED I have connected to this 1A and 2A, and second LED is I have connected to that 1B and 2B circuit. Okay, so hope it is clear. If it is not clear, if you are not clear with the circuit, please ask me in the Skype session. Now we'll again go to the slider, because in slider we have not discussed about the that two LED circuit. So here we have made the one LED circuit. Now the slider is having only 3 terminals. So what we'll do is, so I am making some way out so that I can do the connection. So I am using the second LED. Now the positive is should be connected to here. Now resistor is also required. So resistor. Now positive is connected here. Positive we have connected to resistor. Resistor is connected to positive of this terminal. So that we have connected. Now negative will connect here. Okay, so yeah, so here we have to change something, because if we connect here, this both terminal will get connected, so there's no use of it to connect these two terminals. So we'll delete this line, and the negative should be in the center, because it should be common like this. So why we did this connection, you will understand now. So first circuit will work, you focus here, then you will understand why I have did the connection this way. So first slide connection will be positive resistor LED, and will goes to this, and will go to here. So let's discuss how I did the connection. So positive will go to the resistor and resistor to this LED positive, and the negative LED is goes to slider terminal this, and that terminal, the middle terminal, goes to negative. So when I slide this switch, so I am starting the simulation. So when if I start the simulation, so I have slided this. Now when I have slided, this two terminals get connected. So how the electron will flow? Positive will go to resistor to LED, LED to here, and from this to negative. This way the current will flow. When the slider is that side, so this two terminals get connected. So the electron will flow from here to that LED, LED to here, and back to resistor. So this circuit working like this. So two circuits are working independently. As you switch the slider, the LED will get switched from this to this to this. So this circuit should be clear. If you are not clear, please tell me. I will discuss it on the Skype again. But this should be very clear. This is important to understand how the circuits are working electrically. Okay, so in this way, now you try this body circuit and try to have the different combinations of circuits, try to use the more components and understand how the circuits are working, so that you will learn more and more and more, and try to have the more doubts in your sessions, so in the Skype session, so that you can clear it out more and more. So whatever you are learning in this video, try to get try to grasp the more doubts, note it down all the doubts, and then tell me, ask me during the Skype session, so that we can we can get the more clarity for this course. Okay. Okay, so now go for the practicals, go for this Tinkercad software and start doing this practical now. Thank you.